Hello, everyone. Thanks for all of you that just joined today for the presentation of Streamr Core. This webinar will just give you a quick introduction on what Streamr Core involves and all the capabilities, options that it offers. We will give, I guess, 3 segments. One is, introduction how to use Streamr Core, learn Web3 sign-in and basic smart contract functions via our front-end editor, and also a quick introduction to Core's basic modules, including tables, graph, and other module that you may find useful in managing or dealing with real-time data. We have Tim Oxley, who will give an introduction and quick walkthrough of Streamr Core, and then we will have Jonathan Wolff, who will show some more advanced interaction with smart contract on chain. Tim, are you ready?
I am ready.
Okay.
Jonathan, I think you'll need to stop sharing. If, oh, actually, I can do that. All right. Here we go. Desktop. Okay. Can you see my screen?
Yes, perfect.
Okay, excellent. All right. So, hi, hello, welcome. I'm Tim Oxley. I'm a developer at Streamr. I'm Australian. I live in Singapore. It's 8 p.m. here, which might seem early to you, but I have a 6-month-old daughter, and 8 p.m. is pretty much my bedtime now. So if I seem a little bit sleepy or slow, that's probably why. So anyway, I'm going to give a bit of a run through of some of the new stuff that we've been doing with Streamr's interface. Now, you may have noticed that in the last couple of months, Streamr's got a fairly significant facelift. In particular, the visual editor interface that we have. That's the piece that I've been working on mainly, and that's what I'll try to focus on in this session. So when you first log into Streamr, you'll get some example streams. So streams are sort of like it's like a list of events that happen over time. It's a stream of events. And you'll get some example canvases. If you click on these, canvases are a way of like connecting bits of data together with data transformers and visualizations. This is our visual programming interface. If you look at the example canvases, they'll give you a bit of an idea of what's possible there, all annotated with comments. And you can go and have a explore in your own time to see how those work. So in this session, I'll just go through the absolute basics of using the editor. So first thing, using the canvas editor, let's create a canvas. I just click the create canvas button. Here we have a blank canvas. On the left here, this is the module selector. It allows you to select from a whole bunch of different modules that we can put onto the canvas. You can select them to delete them. We have, I think there's over 100 different modules here that you can choose from. If you click on a module and you're interested in its help, you can click on this little thing and it'll show the help and all of the help for the inputs and outputs on the left here. So what I usually do just to make sure that the interface is working is I'll usually hook up a table. So the table is just like I guess like an HTML table, sort of the table. And then I'll plug some information into it. So let's say we have a random number. We plug this into the table. Then when we hit the start button, we should have a random thing appear. But we haven't, and that's because Streamr, there has been no events. This is just a random number module connected to a table module. It's actually waiting for an event to occur. So we need something to trigger an event, and a good way to trigger an event could be a button. So we create a button, we hook the button's output to the trigger, we hit the start, then when we hit the button, we'll get random numbers between -1 and 1 appearing in our table. Stop the canvas. if you don't want to have to sit there and click the button all day, you can also use something like a clock. So the clock module generates a new event at some interval. In this case, it will generate a new event once a second by default. You can change it to once a minute or once every 2 minutes. I'm certainly not going to demo that. That's way too long. So once a second, we'll click the timestamp. Doesn't matter which one we actually pick here. Into the trigger here, hit start, and then once a second, we'll get a new random number appearing in our table. Cool. If you want to, the table module is actually, it's very good for debugging. So if you want to, anything that you want to just sort of see how it's working, what value it's producing, you can just plug it into the table and it'll show you what the value is in here. So that's probably one of the more useful modules. From here, what we can do is, so we've been generating, well actually here I'll show you about some of the other visualizations. We've got chart module. We'll do some random numbers in that. So, trigger out. Let's make 2. So copy and paste works. I just implemented that this week, so I'm happy with that. Hit the start button, and now we have 2 random numbers. They don't look very random. Oh, I don't understand that, but anyway, it does work. So, so we have our data generated by the canvas, but what we're probably more interested in doing is getting data into Streamr from an external source, and the way that we can do that is through streams. Let's just create a new canvas. So if we create the stream, create a stream module, and then we do something like FBGC, this one, and we plug that into chart, price. So I'm plugging so this stream has a whole bunch of generates events for anytime there's a trade between Ethereum and Bitcoin on Binance, and one of the fields that it exposes is price. And so hopefully there is some trading right now, and there was one. Oh, there we go. So as the trades happen, it logs the price into this chart here. So that's something you can do. And this is a much more advanced version of this, is in one of the demo canvases that were there for everybody when you first log in. But other things you can do, you can actually generate your own streams of data, and that's probably one of the more useful things you can do here. And I'll give an example of that. So, so why don't we'll go to core, create stream. We're going to create a stream. For this example, I'm going to generate machine statistics from my machine. So just stuff about like system stats from my machine. I'll show you how this is going to work in a moment. I've copied the stream ID. I need this in order to publish to the stream. So there we go. I've created that stream. And we go, I'll go to this canvas, that's fine. And we'll create a stream. And we'll have machine stats. So we have the stream here, but there's not really anything we can do with it at this point, because the stream doesn't have any fields configured. So if we go over here, machine stats, we can manually add fields. So if I add in a field here, test, change the data type to like string, for example. And then I go back here, refresh page. Then this fella, oh, hang on, did I hit the save button? I gotta hit the save button. Oh, there we go. So now I have an output on the stream which matches that field. So this isn't very very useful, and this is not what I would normally do. Normally, I just start publishing stuff to the stream, and then allow auto-detect to figure out what all the fields are. But we have to run that before we're able to actually get the fields in the editor. So so how are we going to get the system stats from my machine into the stream? I have prepared something. It's a 42-line node script. So it uses this package called system information to get some information about my system. And it also uses the Streamr client, the JavaScript client, to publish stuff to the stream. So this getStats function just collects a couple of things. So it gets the machine's ID, some CPU load information, CPU temperature, memory information, and battery info. So then I create a new Streamr client using my Streamr API key. So the Streamr API key comes from, if I go here and then API keys, you can add new keys, or you can copy the keys that you already have. So let's say this one here. I've already exported it as a environment variable, so I don't have to keep lugging it around. So you have to supply an API key to the client. Once you've done that, then you can start using the client to interface with all of the streams stuff. If you want to find out the API information there, you can go Streamr JavaScript client. Oh, that should do it. There we go. So it's published on NPM. It's on GitHub. It's open source. All of the docs are here for how to use that. Most of the stuff that you'll need is really publish and subscribe, which is somewhere around here. Well, there's an API for subscribing. There we go, subscribe. So what we're going to do here, yeah, we're just publishing. So I'm going to supply the stream ID to the publish call and the thing that I'm going to publish, which is this stats object, which contains information about my machine. So let's do that. Now, I'm not sure if I've still got that on my clipboard. Oh, thing at the top here. Cancel, go back to the streams, machine stats, copy the stream ID, go back to my terminal, this one. So I'll just show you what it's real. So index.js is the thing that I want. Streamr API, that's not Streamr, what do I call it? Stream ID. Equals, oh, where is it? That one. Node index.js. That should do it. So now this should, if I've done everything right, yep, it's starting to publish these JSON objects to that stream. So you can see here it's changing over time. These are numbers. These are all numbers pretty much except for the UUID, and the battery is this object thing. So if we go back to set up your stream, the auto detect should work, which it does. And you'll see here all of the fields have been automatically detected, which is good, appropriately named. So I'm going to hit the save button. I'm going to go back to our canvas, this one. And now all of the fields that we auto-detected are there for us to do something with them. So from here, just to show that the data is flowing. We'll just plug some of this stuff into the table. Current load, average load, sure, that'll do. Hit the start button, and there we go. I should have made this bigger. Hang on. There we go. So data is flowing. Cool. We could plug that into a chart, and we can see that the average load over time, etc. So from here, maybe mem total, mem used. Those are going to be up. If you look at the data that we're publishing, it's actually I'll do it through Streamr. Use some labels. Mem total, that, and mem used. Labels kind of like it's another debugging tool. These are it's printing in scientific notation because they're fairly large numbers. The amount of memory in bytes for mem total, it's the total. It doesn't matter. It's just data. So what we're going to do is, if we want to actually do something useful with this, we can grab the divide module, and we want to produce like what percentage of my memory is being used. So mem used is being divided by the mem total. Then we multiply that by 100, and we can plug that into a chart. And there we go. It thinks that 95% of my memory is being used, which is probably right. There's various ways of measuring used or how much memory is being used on a machine. So by some measure, that's probably correct. So cool. Now, the one other thing that we didn't cover here was this battery thing. And if you look here, it shows that the battery type is map. It's not like a geographic map. It means like a key value pair, a map of key value pairs. So anything that's a map contains nested values. So what we can do with the map here with battery is we can, oh no, we don't want that one yet. We want map as table. So we can plug the battery into the map as table module, and we can see what's coming out of that. So you can see here, has battery, capacity, percent, etc. Oh, I'm not plugged in. So it turns out I'm not plugged in, which is great. Okay, cool. So that's working. Now let's say we wanted to do something with this. So we wanted to have a look at this percent value. Let's say we wanted to, if the value drops below a certain percentage, we want to do something. Let's say we want to send an email. Well, it turns out we can do exactly this. Well, actually, here we've got one other demo there. I can show AC connected this field. So it turns out that my power cable, these new USB-C things, don't hold the USB plug in very well. So it's fallen out. Now, if I plug it in, this should switch to true, which it does. So there we go, successful demo. Now, so yeah, let's say we wanted to do something with one of these fields. We can use get from map, and it allows us to specify a field name. So in this case, let's say we look at percent, which is this name here, and we want to do something with that. So let's say if the percentage is below a certain amount, so let's use less than. So we've got the, well, I'll demo that label. So I'll just show that this is working. Hit the start button. This should say 76. So we just got that one field out of the map. So if the percentage is less than 10, then this output here will be true. So we could do something with that. So one thing we could do is, for example, send an email to ourselves. We have an email module. You're not able to use it to send to other people. It'll send it specifically to the address that you registered with Streamr. But we can get it to email us if this condition is true. This is going to take some time for me to drain that amount of battery. So instead of doing that, why don't we do something, instead of %, let's use AC connected. So when AC connected is false, let's email something to ourselves. So we need the not module. Oh, actually, here we go. Let's formulate something a little bit more. So this message, it allows us to have any sort of custom message. So we can use a string template module. We can plug the battery directly into that. So this args thing takes a map, and then we can type in a template. The template here, there's a cheat sheet for the syntax. Oh, not that one. There's a go there. So there's a whole range of syntax stuff there, but you don't need to know most of that really. You just need to know that you can say battery low, battery %, battery is at %, and then we say AC connected is AC connected. So let's just have a look at, I'll use the label again. See what that looks like. So if I hit the start button, battery is at 78% connected true. I'm going to disconnect it. Wait for a moment. There we go. Connected false. All right. So cool. So that's generating a sensible label. We can then plug this string in as the message. Set the subject to battery low or battery disconnected. And see this this blue one. This is a driving input, and what that means is that whenever this value changes, this module gets triggered, and that's why before when we looked at the for example the what was it? Or for example, if we look at any of these ones that have a trigger input, the trigger input is blue. That's because it's a driving input. Whenever a blue thing changes, that module gets activated. So here, whenever value 1 changes, then it will this email will be activated. So what we're going to do is we're going to do sample if. So sample takes a value. So we're going to take the battery map, and it will trigger this value if this thing is true. So we need a not thing in here. So if it's not connected, then we want to trigger it to pass something to this value, the driving input on the email. In this case, it'll be the battery value. It'll be like that map thing, and then it should send an email. So battery disconnected, AC disconnected is probably, but I have to have the word battery because that's what I'm searching for, I think. Anyway, well, if we start this, connected. Now if I disconnect this, and so I've disconnected my power, AC connected is false. Now if I go up here and search for battery, there we go. I got an email at the right time. So, and let's have a quick look at that. So it includes a link to the canvas. It has the formatted text that I put in there, and it also generated that battery object that I sent it got formatted into this weird looking thing that gets printed here. So yeah, that's my short little introduction to the canvas, the editor, Streamr Core stuff. So we're producing data here using the JavaScript client. That's not the only way that you can produce data. You can produce data there's a Python and a Java client. And there's also an HTTP API. If you go to API Explorer, Streamr, not in my autocomplete. It'll be on my other thing. Hang on. Hold on. Let me just sign in my other account. API, there it is. See, I never know what anything is anymore because autocomplete does it all for me. So we have api-explorer.streamr.com, and it has all the documentation for the HTTP API. So pretty much everything that we just did can and probably was done through an HTTP API, which you could write your own client for or integrate into your own product. Yeah, that's me. That's the end of my webinar.
Okay, thanks a lot, Tim. I think we have a question from the audience for you.
Sure. Once I figure out how to get back to the Zoom interface, hang on.
So I can read it to you.
Sure.
So they were asking like, how does the auto detect function work when you have like a variable number of fields headers from the data being sent?
Yeah, so that it won't work very well. So when you've got a stream of data, you generally want to have the same set of fields going through. Otherwise, it'd be difficult for anything to work with it because the data shape is going to be changing. So what you'd want to do is make sure that the fields stay the same, because I think it'll look at the last event that's come through and use that as the basis for detecting the fields. Probably it would be, even if the Streamr system could sort of dynamically deal with that, anybody that's consuming data with like variable fields is going to have a real problem, just because you know, they're going to have like checks around everything to see does that field exist or not. So the answer is ideally that your data wouldn't do that.
Okay. I guess an alternative to that scenario would be like if the data producer knows in advance all the fields that the I guess system or IoT sensor sends, so they can create a super.
Yes, of course, yeah. So you can, yeah, of course. So if you want, you can always fill your own fields in, yeah. So it just turn off the auto detect and manually the fields. That's a more correct answer.
Okay. Yeah. Okay. So in case of that scenario where they fill out all the available field, the only issue, I guess, when the field value changes is like a lot of those will be empty, right? Like.
Yeah, exactly. Yeah.
Okay.
Fine. Yeah.
Yeah. Another follow-up question from Gareth is how to deal with nested JSON objects. So I think during your presentation you showed the map table, right?
Right.
I was wondering if you can just show again, like just maybe a little slower to show them like in the raw table format and then the map table, what exactly you know.
Sure.
You are.
So this stop. So this battery field is a map. If you got nested, you could get from map and then so you could get the map out of the map if you needed to. And then you could plug that into mappers table. So this mappers table thing, this battery thing is like a single field that contains nested values, nested key value pairs. And then if you had nested again, you could yeah, use something like get from map to extract those in the same way that you extract any other field. So that the output on this is whatever the value type that is extracted. It's not sort of fixed.
Okay, great. Okay, Gary say it makes sense. Great.
Okay.
Glad we were able to answer. So we have a question from Allard. So if I want to input data from the other platforms on my custom tool, how should I start reading up the HTTP API? I guess in order to answer that, the easiest way is to actually to go to our Streamr docs, and we have API section, but also very quick intro with how to work with API, like both like HTTP examples and via our libraries. So I think we mentioned briefly in our tutorial example. How to create and publish data to a stream in a simple pub subsystem that has the library, JavaScript library example, but also I think HTTP example about how to.
I think it's probably easier unless you're. It's probably easier to use one of the client libraries than it is to use the HTTP calls directly, unless you can't. But I mean, most environments support JavaScript. JavaScript runs everywhere, so if it was me, I would, even if your environment doesn't run JavaScript, make it run JavaScript and then use the JavaScript client. That's what I would do, rather than calling the HTTP API directly. I mean, you can. There's nothing wrong with it. It's just there's a little bit of handshaking and some details which you can gloss over if you use the one of the client libraries.
Yeah, that's true. If you scroll down a little bit, Tim, okay, right there, you can see example of our HTTP post, the API to call, and an example with Postman. Like you can actually, if you are just wondering how to start just, testing, you can use the app like Postman to send HTTP without any, code involved. So you can maybe try to duplicate, for example, a stream in your canvas and with the modules as lowest hanging fruit. But yeah, if you want to do any production level, we highly suggest libraries because the throughput actually via WebSocket is much higher too. Okay, now we have, if there's no further questions for Tim on the Canvas editor side, we'll be switching to Jonathan, who will give a quick overview of how to interact with on-chain smart contracts via our Canvas directly.
Hi,
cool.
Thanks, Tim.
Great. Thanks.
Yeah, let me share my screen here. Okay, so can you see my screen now? Yes? Okay, I hope everyone can see my screen. Can you hear me okay? Oh.
Yeah, we can hear you. It's
yes,
all good.
We can hear you.
Aha, we can't hear you now. You've muted
You
yourself.
went on mute, Jonathan.
Hello?
Yeah, perfect.
Yeah,
okay.
All good now.
Okay, and you can see my screen, right?
Yeah.
Okay, great. I'll be going over Streamr's Ethereum module. So these are specific Canvas modules that allow you to interact with the Ethereum blockchain. And you might want to do this if you're creating streams and selling them on the Streamr marketplace. But it's also a useful tool for just automating your Ethereum jobs. Say you're like an Oracle and you want to post regular data to the Ethereum blockchain. This is a useful tool similar to Cron, with a graphical interface where you can set up your Ethereum jobs. So I made a test canvas, and I'll go through the different elements of the test canvas. So the first thing here is Solidity compile deploy, which is what you use to actually compile your Solidity code and deploy it on the blockchain. So what you do is you set up your private keys. So with the canvas, you would set up your Ethereum accounts this way. You'd add your private keys here, but you also have the option to run this entire stack in a Docker image. So I'll go over that at the end of this presentation. But your options are basically to give us your private key or to run it locally, in which case you can keep your private key private. So in the case of private keys that you give Streamr, you probably don't want to store a lot of value on that, but that allows you to use streamr.com to generate streams that you can then sell in the marketplace. But it's also perfectly possible to run this all locally. So I configure my keys in that area in the Ethereum account section, and I just copy and paste my private key. So in this case, we'll be using the Ropsten network. So we won't be transferring real Ether, paying for our transactions in real Ether, but it works exactly the same in the main network. And you can see that you're in the Ropsten network by going to the top right corner. You get the options for each module. And in this case, you'll see network is Ropsten for all the different modules. So one thing, you have to set the network to Ropsten for all your different Ethereum modules. So that means you have to set it in the Solidity compile deploy module. And then there are two other Ethereum modules I have here. One is Aetherium call, which is the one that is actually used to make function calls in Ethereum. So this can do constant function calls and transactional function calls that actually generate an Ethereum transaction. And then the other module that I have here is the get events module, which we'll use to listen to events. So even if this canvas did not trigger the particular event, it would still pop up here. And this works over WebSockets. So, there's one other Ethereum module that's not in this canvas, and that's the get contract at module. And that would be used in case of the in place of the Solidity compile deploy module, in the case where you already have deployed your contract and you have the ABI, and in that case, that takes as input an ABI and an address of the contract. So I'll look at the code here. So I'm in the edit mode now. You can see I'm in the editing mode, not in the running mode, but because the start option is available here. So when I go to edit code here, I have the code for this very simple Solidity contract that I made, kind of a toy contract that's a stock ticker. And the stock ticker has one function called update price. And there's a contract owner who's the contract creator, and only the owner can run the update price function. And when the owner updates the price of a given stock ticker, it triggers an event, a price updated event, and other people might listen to that. That's the demo we have here. But there are basically any Ethereum code you want to write, it should be fully compatible with Solidity. So any Ethereum code you want to write, you can compile it here and then configure inputs and outputs. And another useful feature I should mention is that, as Tim mentioned, you can have as input to these Ethereum calls HTTP requests, for example, if you're scraping some other site and posting that data to the blockchain, or you could even have your own stream as an input module. So you could post the data over HTTP yourself, push it over post, and then that would trigger an Ethereum call each time. But in this example, I'm just going to use a button module to trigger it manually. So this is my stock ticker. This is a simple code that I have. I've already deployed it, but if you want to deploy it again, you can press apply here, and then you'll have the deploy option will be enabled here, and you can press that, and then it would deploy it again. And you would see the transaction instantly when you press deploy on Ropsten. So in this case, I already have it deployed, so I'm not going to deploy it again. And once you deployed your contract and it's compiled and it's deployed, the contract output over here contains both the ABI and the address of the contract that you just deployed. So the contract input, which is then the contract output of Solidity compile deploy, which is then piped to get events and Ethereum call, contains everything you need to make Ethereum calls and listen for events. So I'll first take a look at the Ethereum call module. So once you connect a contract, it auto-populates this list of functions over here. So you can just choose the function you want to run, and based on the ABI, it will configure the inputs for that function. So for this simple contract, you see we only have one function, this update price function, and that's the only one I can select here, so I'll use that. You can see I'm also selecting the key that I'll be using to make the function calls, and that's the same one that I used to deploy over here, so that's actually the owner of this contract. And as inputs to the function, I have a ticker symbol, which is in this case Streamr, and a clock module, which generates my timestamp. And there's one thing to note about the clock module here. You can see that this DI button is disabled. That DI means driving input. So driving input causes the module to execute whatever it's programmed to do. So if I didn't have this, if I had this driving input enabled, every time the clock ticked, which is in this case every 5 seconds, it would actually trigger an Ethereum call. So we don't want that in this case. We just want the driving input to be this button over here. And the button value, which contains a integer, is 1337, which is the price of this fake stock. And so when I press the button, when it's in run mode, it should actually trigger an Ethereum transaction. And then this contract also goes to the get events module. And the get events module, like the Ethereum call module, is all configured by the ABI that you specified. So errors and transaction hash, these are present in all of the get events modules. But the ones below, you can see that these are the fields for this price updated event. So you can see in the price updated event, I have 4 fields over here. I have, by the way, the string as an index, the symbol of the stock as a pure string and an index string. The reason I have that in this contract is that indexed variables in events are actually passed as the hash. So they're indexed by the hash. So if I looked at the index symbol, I would only see a hash of the symbol, whereas if I see the pure symbol, that actually passes the raw string. So there's a slight nuance in the way that index parameters and non-index parameters are passed with events in Ethereum. So just be aware of that. So these outputs are just the modified strings of the parameters to that updated price event, and they're all auto-generated by the module. So so now when I press start, it should start up my module here, and I will trigger some transactions. So when I press this, this should trigger some transactions in the Ropsten network. And I will go to Ropsten here to make sure that these transactions are actually being triggered here. So you can see that it just triggered some transactions. And when they confirm, we should see the transactions in this window over here. So the get events just, let me close this. The get events module is just passed event information from the contract you're listening to. So are they still pending? Sometimes there is some lag. We use Infura for our backend, so in some cases the events don't come through instantly. We have to wait till Infura pushes them to us. And I've heard also that Ropsten is less reliable than other networks, than Ring could be a main network. So I'll try this again to make sure that we are getting pushed these events. But there is a few minute lag in certain cases. We have some new transactions being triggered, and eventually Infura should push these to us. So, but I also have the outputs going to ascend to stream. So while we're waiting for the events to be received, it may take a few minutes. I'll go over that. I've created a stream here called it's a demo stock ticker, test stock ticker. And you can see that all the symbol, timestamp, and price and way are in the stock ticker stream. And so the get events output should actually output this to the stream also. So when that's finished, we should see it here also. Yeah, we may be experiencing some lag here. Well, I will hope these events come in. These are actually still pending transactions, the latest, pending confirmation, the latest I just sent. One other thing to note about this is that you can run the entire image, you can run this entire stack with a Docker image. So if you go to GitHub, there's a link, Streamr Docker Dev over here, which runs the entire Streamr stack locally. So when you're running Streamr on Streamr.com, you have this reliable peer-to-peer network for stream distribution. When you run it in the Docker image, you don't have that. But the advantage is you could also store your private keys privately in the Docker image. You don't have to give them to Streamr.com to be stored, to be used in transactions. So you can automate your Ethereum jobs with just on your local machine without actually giving your private key to another party or relying on a third party. So this canvas can be used as a tool sort of similar to cron. I'm not sure if these events have come through. Let's see. In certain cases, I've seen the events not come through, especially on the Rockstar network, but I believe that's because Infura is not pushing them to us. But I'll try starting the stream again, the canvas again. And if it doesn't happen, it doesn't happen. Let's see. Oh, one just came through. Okay. So here's an example of a transaction hash that actually came through, but it's usually more reliable than this. I have experienced this before where certain events are not, I believe, not pushed to us by Infura, but I think this only happens in the Rockstar network. So, and sometimes I've experienced this where they're pushed 10 minutes later. So I'll end my talk here, but basically the events, we'll see if the events are populated here. They might just lag 10 minutes. But are there any questions about how to use the Aetherium modules? I'll take questions now.
Thank you, Jonathan. As you can see, this was a very quick overview of how you can actually, deploy even smart contract on Ethereum via Solidity. In general, directly from the Streamr Core UI, and also like how you can interact with these contracts, directly via editor. The power of that is like you don't need to deploy any front end, like framework like React or anything else. You can test your contract, deployment, and also like logic via Canvas. And then once you're satisfied with the result, maybe you realize it's worth a while building the entire front end to interact with the dApp or decentralized app. We are going to switch quickly to some of the questions. Let's see. I think Ben, he had a very good suggestion, which was instead of switching networks for each module manually for all of them in order to make the whole flow work, instead to allow the network choice as also input, which means probably like having like a input module that selects the network and then connect to all the modules. So it's
yeah, I actually agree with this because it's always driven by a contract module, so that contract object. So that contract object could contain a network also that's passed on. So I agree with that suggestion.
Okay, yeah, yeah, I totally agree too. That sounds much more plausible. Because one of the issues we had with some users was exactly that they could not find the error because they realized they had one issue with one module not being switched.
Yeah, and it is redundant. I mean, there's no reason you would use the contract address for a deployed contract on one network with a get events module from another network. That makes no sense. So.
Mm-hmm. Okay, next question. So. Gareth, have you guys considered integrating with other smart contract platform like Zilliqa or Tezos? Jonathan, do you have anything on the pipeline regarding this, or I mean, I have a general answer, but I just wanted to check.
No, actually, no, I have nothing to say about that. I don't know of any plans to do that.
Okay. Well, from our side, yes, there's nothing that will stop us from integrating other, smart contract, let's say blockchain platforms. And the entire actually Streamr stack, including our network, is meant to be almost blockchain agnostic, meaning like if something happens to Ethereum and there's other solutions that have like solved some of those like scalability solutions or micropayment issues, then yes, we could switch over. The rationale for integrating with, of course, Ethereum in general is due to the large ecosystem and community, and also time constraints on our side, as we have to decide. Okay, so any other question from the user side? Okay, no questions. Perfect. So I just wanna, I guess, end the webinar with thanking both Tim and Jonathan. The presentation has been great, and if any of you on the audience has any further question, feel free to send us any message via Telegram and our forum, which is, let me share the link directly in the chat. In the forum, you can ask any technical related question if you have any issue with integration, and any other related questions, API, HTTP request, etc. Alan just sent his thanks for everyone. Thank you, Alan. No, Allard, sorry. Very glad to hear like you are enjoying it. Okay, that's it. And for those people that will be watching the video later, yeah, feel free to reach out via our normal social media platforms or like forum. The last in the parting, I guess, quick tip is if you go to our canvas, you will see a neat a shortcut keyboard icon there. So if I can just share my screen. So can everyone see my screen?
Yep.
Okay. As you can see here, there's like a very useful shortcut section where it tells you how to do certain things. For example, I think like delete module is the main one that some people ask because they cannot currently delete modules on the front end via, let's say, mouse. You have to use your keyboard delete, but you can also do like copy and paste that Tim just implemented too. So that's it. Thank you, everyone, and we'll be ending the webinar now.